Hello everyone. Let's do more examples of integrals involving powers of sine and cosine. In particular, let's look at examples where both powers are even. So our first example, a classic question, let's integrate sine square of 3x dx. Actually, this one, if you're really clever and crazy, you can do it by part, but we're going to use trig identities to do this one. So here we have sine squared. So the m value, the power of sine is 2, so it's even. And the power of cosine, because it's not there, it's 0. Okay, so when one of them is missing, then the corresponding power is 0. So here, of course, what's really important to notice is that both powers are even. So we are dealing with the last case where we need to get rid of these even powers by using the trig identities, either 3 or 4. So those doubling angle formula. So here, because we have sine squared, we're going to use the fourth trig identity. So I'm using the fourth trig identity. So here the theta, whatever stuff you have inside sine squared. So the theta is 3x. So here, if you're using the fourth identity, this sine squared is going to be replaced by 1 minus cos of 2 times what's inside. Because the inside is 3x, you're going to get 6x. So it's 2 times 3x, which is 6x divided by 2. So here I'm using the fourth trig identity to get rid of sine squared. And now it's good. We're down to a cosine power 1. We're basically done with this. I'm going to bring the 1/2 outside as a coefficient. So you get 1/2 the integral of 1 minus cos of 6x dx. So the integral of 1 is just x. So you're going to get x, and then the integral of cosine, it's sine, but of course, because the inside is 6x, you need to divide by 6, and then you just go plus c. And now, finally, if you just multiply by 1/2 throughout, you're going to get x over 2 minus sine of 6x over 12 plus c. And that's it. That's all. So by one application of the trig identity 4, we got a simpler integral. Basically, here you don't really need a u substitution. You could argue that, maybe the 6x, you could call this u, but whatever. If you know your tricks, the integral of a primitive for cos of 6x is sine of 6x divided by 6. Anyways, you get your final answer pretty quickly. Anyways, let's do another example. All right, next example. Let's integrate sine squared of x times cos squared of x dx. So the first thing you do is you label your powers. So here, the power of sine is 2, and the power of cosine is also 2. So both are even. So we need to use trig identities to get rid of them. So the sine squared, the way you're going to get rid of sine squared is by using the fourth trig identity, using the double angle formula, and then to get rid of cos squared, you're going to use the third trig identity. And then this will become this brand new integral. So sine squared will blow up. Because the inside here is just x, we're just going to multiply x by 2. So you're going to get 1 minus cos of 2x over 2. So this is the result of applying the fourth trig identity. And then the cos squared will blow up into 1 plus cos of 2 times the inside. So here the inside is just x. So you're just getting 2x over 2 dx. So this comes from the third trig identity. And now you just need to FOIL. So I'm going to spare you the detail, but the two denominators, 2 times 2 is 4. So I'm going to take out the coefficient 1/4. If you FOIL this, you're going to get 1 plus cos of 2x minus cos of 2x plus or minus cos squared. So if you FOIL correctly here, you're going to get 1 minus cos squared of 2x. So do it if you're not sure. So just FOIL and simplify. But now we're stuck with another even power of cosine. So we need to apply again the trig identity 3. So now we get 1/4 the integral of 1 minus, open a bracket, just be careful here with brackets, 1 plus cos of 4x. Remember, you're always doubling the inside. So if your theta now is 2x, it's going to become 2 times 2x, which is 4x over 2. dx, a little bit of simplification here. If you remove the brackets, you're going to get 1 minus 1/2 minus cos of 4x over 2. So you're going to simplify the 1 minus 1/2 and just get 1/2 minus cos of 4x over 2. So let me just rewrite the x here. dx, and now you're done. 1/2 will go to 1/2 x, or x over 2. Cos is sine. The inside is 4x, so you need to divide by 4. The 4 times 2 is 8. Now you're done. Plus c, if you multiply by 1/4, this simplifies to x over 8 minus sine of 4x. 8 times 4 is 32 plus c. And that's it. That's all for that example. So really the last case, the third case, where everything is even, you just repeat applying the third and the fourth trig identity, and you're going to end up with powers of cosines, which are all 1. So you can just use basic substitution, just a linear trick to get your final answer. Anyways, too much talking here. So that's actually the end for that little section. We're going to move on to the next section, which is now the infamous trigonometric substitution that we all love so much. All right, for that video, that's it. That's all. Bye-bye.